हाँ सर, वो मैंने लाइट भी ऑन किया तो शायद। Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter relations and functions. So if you have any if you have any questions regarding a- any question or its solution, then please write us in the comments section. And if you feel that you have more difficulty in any chapter, then also please write us in the comment section, so that we can solve more and more questions on that chapter. And homeworks on every chapter will also be given in the Sapience education app. So please install our Sapience education application, whose link has been provided. So we shall start from the question. So here it is written that on the set Q of all rational numbers, so Q is the set of all rational numbers, and set Q, the operation uh, star, which is both associative and commutative, by A star B, that is equal to, okay. So here we have to find which of the binary operations is associative also and is commutative also. So here one is A plus B plus AB, A star B is A plus B plus AB, and then B star A, that will be B plus A plus BA. So it is, so the first one is commutative, and for associative we should have A star B star C, that will be equal to A star B star C is B plus C plus C. A star will be A plus B plus C plus BC plus A into this B plus C plus BC. But we do A star B star C, then that will come A plus B plus AB star C. So that will be A plus B plus AB, then plus C plus A plus B plus AB C. So they are not obviously the same. So the first one is commutative, but it is not associative. And in the second one, A square plus B square, A star B is A square plus B square. That is also same as B star A, since B star A will also be square plus A. It's same. Second one is also commutative, but we have to check if it is associative or not. So A plus B, A star B star C, so that would be A square plus B square star C. That would be A square plus B square square plus C square. and A star B star C, that will be equal to A star B square plus C square, that would be A square plus B square plus C square square. They are not. So here in the second option, the operation star is commutative but not associative. And in the third option, where A star B, that will be same as B star A. Since AB plus 1, that will be also same as BA plus 1. And we have to check if it is associative or not. A star B star C, that will be A star B star C, which is BC plus 1. So A star BC plus 1, that will be A into BC plus 1 plus 1. So that will be ABC plus A plus 1. Then A star B star C, that would be equal to A AB plus 1 star C. That would be AB plus 1 in C plus 1. The ABC plus C plus 1. So they are not same. So in the second one, so in the option C also, the operation star is commutative but not associative. And in the option D is 2A plus 3B. So therefore A star B so the first option, I think we some mistake we have done. If we expand it, this will come A plus B plus C plus BC, plus it will be AB plus AC plus ABC, and here it will be A plus B plus C plus AB plus AC, B plus AC plus BC plus ABC. So these two are same. So therefore the in the first option only, this operation star is commutative also and it is associative also. So option A is the correct answer. And in the option D also, you can see that it is not commutative, since A star B will be 2A plus 3B, but B star A, that would be equal to 3A, so that would be 2B plus 3A. So they are not the same. Therefore, the first option is the correct answer, since here the operation star is both commutative also and it is associative also. Commutative since A star B equals to B star A, and it is associative also since A star B star C equals to A star B star C. Then second one, if here the set A has been written A, B, C, the set B has been written B, C, D, set C has been written A, D, C. Then we have to find the set A minus B cross B star B intersection C. It means we have to find the Cartesian product. Cartesian product. So regarding any question, any doubts if you have, then please write them in the comment section. We shall clarify them. A minus B, it means we have to do A intersection B complement. Means, or we can say A minus B, that is equal to A minus A intersection B. We have to exclude those elements which are common to A and B. That will be the set B and C are common, so that will be the element A. And B intersection C, that is we have to write the set of the common elements in B and C. That would be C is common. C and D are common. So therefore the Cartesian product we have to set A cross C, that would be, so we have to write all the possible ordered pairs. So that would be A comma C and A comma D. So second one also it is option A. Option A is the correct answer. Then here it is told the function f which maps x to y is defined by f of x equal to sine x, that is 1 1 but not on 2 if x and y are respectively equal. So it is 1 1 but not, it is not onto, means that the range should be equal to the co-domain. But so if the range of the function f, the range of the function f is a subset of the co-domain, then only it means that the range is not same as the then only we can say that the function f is not onto. You know that sine x, the domain, the graph of sine x is minus pi by 2 to pi by 2 is this. This is minus pi by 2, this is pi by 2, and it's pi, it's pi by 2. Yeah, it's 1 1. The domain of the function f is obviously the range, will be all real numbers are, and the range will be from minus 1 to 1 actually. So if we take the range as, if we take the co-domain, we take the codomain as R, then only we can say that, function f is not onto. But then if we take the domain as R, then the range, okay, then it would not be 1 1. So if it has to be 1, then 0 to pi by 2. Yeah. So if we take from 0 to pi by 2, so if we take that x is greater than or equal to 0 and less than or equal to pi by 2, sin x will obviously go from 0 to 1. So it will not go from minus 1 to. So therefore, if we take here the codomain, as minus 1 to 1, then it will not be onto. Since why these values are not included. Okay, since minus 1 to 0, these are not included in the range here. So option C is the correct answer. Since why here the domain has been given as 0 to pi by 2, and the range is coming, the range of the function f in that case it is coming 0 to 1, but the codomain has been given as minus 1 to 1. So range is obviously a subset of the codomain. Hence in this case the function is not onto. Okay, then if here it is told if the function f maps from R to R is the set of all real numbers, function f of x is given equal to x, which is the absolute value of x. So then f inverse of x, the graph will be like this. So it is not 1 1 1 2. It is, so here we can see that the range of the function f is 0 to infinity, and the domain the domain of the function is all real numbers are. Therefore, here the range is a subset of the domain which is given as. Therefore, it is not onto. It is not, and it is not 1 1 also. Since why? Suppose, for example, absolute value of -3 is same as 3, which is 3, but -3 is not same as, so it is not 1 1 also. So we know that f inverse, the inverse of a function, will exist only if it is 1 1 and onto. It should be a bijective function. F inverse x will exist only if f is 1 and on. Means that if the function f is a bijective function, then the inverse of the function f will exist. So hence option C is the correct answer, that the function f inverse does not exist since it is neither 1 1 nor onto. Then this then the question f on the set z of all integers star is defined by a star b, that is equal to a plus b minus 5, that is given 2 star x star c 3, that is equal to. So here star is a binary operation. In and it is defined on the set of all integers. So x should be an integer here. So, so it will be 2 star x star 3 means it is x plus 3 minus 5 equal to 5. So then 2 star plus 3 minus 5, that will be, this is x minus 2, 2 plus x minus 2, 5, 5. So then we can say that this will be 2 plus x minus 2 minus 5, that 5. So plus 2 and minus 2 will cancel. X equal to 5 plus 5, which is 10. X is equal to 10. So option B is the correct answer. Then, so in any questions or in any solutions, any doubts if you are having, then please write them in the comment section. We shall obviously clarify those. Which of the following is false? So if a star b, that is equal to a raised to the power b for all a comma b belongs to the set n, then star is commutative in n. No, it is not so. Since why, if you do like 2 star 5, 2 star 5 will be equal to 2 raised to 5, which is 32. But if you do 5 star 2, that will be equal to 5 raised to 2, 25, which are not same. So they are not, and 2 and 5 are natural numbers. So option A is not correct. So it means that option A is false. Here it is asked that which of the following is false. I think A is the correct answer, and we should check A, B, C, and D also. Addition is associative in N. Addition is associative in N. Yeah, it is true. Addition is commutative in N. Yeah, that is also true. Multiplication is associative in N. Yeah, that is also true. So it means that B, C, D are true. C and D, they are true. But only option A is false. Option A is the correct answer. F is a function which maps from R to R. R is the set of all real numbers. It is defined by f of x equals to x cube. And then, so f inverse 8. We know that, therefore f of 2 that is equal to, so here f maps from R to R. We know that the graph of the function is like this. So the graph of the function y equal to x cube is like this. So here we can see that it goes from minus infinity to t. So and it is 1 1 and on 2. But the function f is 1 1 also, and it is on 2 also. Therefore you can say that f of 2 is 2 cube, that is 8. So f inverse of 8, that will be equal, f of x is x cube. So I can say if y equal to x cube, then I can say x is equal to y power 1 by 3 is equal to f inverse. So it means f inverse x, we can say that is equal to x power 1 by 3. F inverse 8 is 8 raised to 1 by 3, which is f inverse 8, that is equal to C. Option C is the correct answer. 2. And then R is a relation on the set N given by R equal to, R is the relation which consists of all the ordered pairs x comma y, such that 4x plus 3y that is equal to 20. Which of the following belongs to R? Now, we take the ordered pair 3 comma 4. So then 3 and 4 both are natural numbers, but if you do 4 into 3 plus 4, 3 into 4, so that is 12 plus 12, which is 24, which is not equal to 20. So the first option is wrong. So 3 comma 4 does not belong to the set R. 3 comma 4, the ordered pair, does not belong to the relation R. Then the option B is given as 2 comma. So 2 and 4 both are natural numbers. Here R maps from the set N to N, means the x and y both should be natural numbers. Here x and y both should belong to N. So 2 comma 4, if you do so, then 4 into 2 plus 3 into, so that is 8 plus 12, that is equal to 20. So 2 4 belongs to the relation R. And in option C is written minus 4, but minus 4 does not belong to the set N. It is not a natural number. So therefore it will not belong to the relation R. And similarly, the option D also is wrong, since why 5 comma 0 is written, but 0 is not a natural number. So 5 comma 0 also does not belong to the relation R. Option B is the correct answer. Then question number 9. So here also, on the set of all natural numbers n, which of the following star is a binary operation? So here star is a binary operation on the set n. It means it maps n cross n to n. So here the both a and b should be an natural number also, and n should be, and the output should be natural number also. Here both the inputs a and b should belong to n also, and the output also should belong to the set n. A star b also should be set n. Okay, so then here the first option, a star b equal to a plus 3b. So it means that if a and b belongs to n, then a plus 3b also will be a natural number only. But in the second case, a star b is given as 3a minus 4b. 3a minus 4b. So this may not be a binary operation. Since why, if you take A as 5, B as 1, so then 5 star 1. Yeah, so if you take A as 1 and B as 5, suppose, so then 1 star 5, star 5, that would be equal to 3 into 1 minus 4 into 5, which is 20, which is equal to minus 17. So the output is not a natural number. It does not come to the set n. Therefore, option B, this binary operation star, is not option. Option C also, if you take A star be equal to root AB, so if you take like 2 star 3, that is also of 6, which is not a natural number. Does not, it is not a binary operation on the set n. And D also, here also, if you take like 1 star 3, that will be 1 minus 3 by 1 plus 3, which is not a natural number. So D also, option D also, the operation star is not a binary operation. So only the first option, which is A star be equal to A plus 3B, this is the only binary operation, and A is the correct answer. Then question number 10, here it is written, the set integers Z, define the function f maps z as f of n equal to, which is n by 2 if n is even, and it is equal to 0 if n is odd. Then the function f is surjective but not injective. So we have to check if it is surjective or it is injective. So it is injective if it is 1 1. Injective means it is 1 1. If it is a 1 1 function, then it will be injective. And surjective means it should be onto. Injective means it should be on. Here, set of integers. So if n is even, n by 2 will be an integer. So n by 2 belongs to z for all n even number, for all even number n, all even, for all even integers n, and for all odd numbers it is 0, all odd numbers it is, so if you do like even, so if f of 0 will be, so 0 is an even number, 0 is even, so f of 0 will be equal to 0 by 2, that will be equal to 0. And any other odd number if you take, that is suppose if 3, that will be equal to 0, since 3 is an odd number. So it means that it is not 1 1, since f of 0 is equal to 3, but 0 is not 3. So the function f is not 1. So it is not injective. It is not. But here, for all, if n is an even number, suppose if n is, an even number, it is divisible by 2, then n can be of the form like 4m plus 2, or it can be of the form 4m if n is even. Since by 4m plus 1 and 4m plus 1 will be odd for any integer m. So n by 2 can be of the form 2m also, or it can be 2m plus 1 also. So it means that all the odd numbers also will get included and all the even numbers also will get included. So therefore, the function f is on. Function f is on. Since all odd numbers and all even numbers, even integers are included in the range. Included in the range function f. So therefore now, so it means that the function f is onto, it means f is surjective. Surjective means that the function f is surjective but not injective. So option A is the correct answer. Okay. So any steps, if you are unable to understand, any doubts if you have, then please write us in the comment section. We will clarify them. Then let R be an equivalence relation defined on the set containing 6 elements. R be an equivalence relation. Equivalence relation, it means that it is reflexive. R is reflexive, symmetric, and transitive. Reflexive, symmetric, and it is transitive. Then it is called as an equivalence relation. And R be an equivalence relation defined on a set containing 6 elements. Then the minimum number of ordered pairs that R should contain. Number of ordered pairs that R should contain. So 6 elements. So let A be the set. It contains A1, A2, 3 till A6. So R is an equivalence relation. So R should contain, it means that A comma A should belong to the relation R for all A belongs to A. Then it will be reflexive. So it means that R should contain like A1, A1, A2, A2, all those it should contain. And till A6, A6. So all the every element should be related to itself under the relation R. Then only it will be called reflexive. So 6 ordered pairs it should have at least. And then symmetric, it means that if A1, A2 belongs to A, then A2 comma A1. So if A1, A2, A1 comma A2 belongs to the relation R, then A2 comma A1 should also belong to the relation R. Then only I can say that the relation R is symmetric. But here if this A1 comma A2 is not there, then also it will be symmetric. Also it will be symmetric. So it means that if these elements, it means A1 is not related to A2 or A1 is not related to A3, then also it is okay. Means then also it will be symmetric and transitive. And since transitive, it means that if A1 comma A2 and A2 comma A3 belongs to the relation R, then it implies that A1 comma A3 also should belong to the relation R. But since A1 comma A2 and A2 comma A3 are not there, so it is not necessary that A1 comma A3 should belong to the relation R. So since these are not there, so it will be called as transitive also. It means that if all these 6 ordered pairs are there where every element is related to itself, then the relation R will be equivalence relation. It means that if only it is reflexive, then only simply you can say that it will be equivalence. So the minimum number of ordered pairs that it should contain is 6. So option A is the correct answer. Should contain, so minimum number of ordered pairs should be 6. Minimum number of pairs be 6. Okay. Then in P of x, which is the power set of a non-empty set X. So P of X is called as the power set of the set X. Power set of the set X. It means it is the set of all subsets. Set of all subsets of X. Set of all subsets of X. It means that P of X should contain the element phi also, which is a subset of X. Since an empty set is also a subset of every set, it should contain phi and all the elements of X, and it should contain the set X also. Since X is the universal set, so it should. So it means that the set X itself is a subset of the set X. So the should be an element of the power set of X. So here a binary operation star is defined on the power set of X, where A star B, A and B are two sets, A star B equal to A union B, for all A and B belongs to the power set of X. So under the binary operation star, a true statement is inverse law is not satisfied, identity law is not satisfied, but identity law will be satisfied since A star phi, we take A star phi equal to phi star A, that will be equal to all set A belongs to the power set of X. So phi, if we take, since phi union with any set, phi union that is equal to A union that is equal to, so phi is the identity element. The null set or the empty set phi is the identity element under the operation star. It is the identity element under star, the operation star. Then here associative law is not satisfied. It means that A star B, that A star B star C, that will be equal to A union B union C, and which is also equal to A union B union C, is also equal to A star B star C. So it is associative. Hence the binary operation star is associative law is satisfied here. And so identity law is also satisfied. So option B is also wrong, C is also wrong. And then in the option D, it is told commutative law is not satisfied. So option D is also wrong. So A union B equal to B union A. Therefore, it means that A star B, that is equal to B star A. That star is a commutative binary operation. So only the inverse law is not satisfied, since there is no such element B where A union B equal to B union A, that is equal to the identity element phi. This is, can't be phi for any B, any set B belongs to the power set of X. So it means that identity law, inverse law is not satisfied. So inverse law is not satisfied. Right? So that option A is the correct answer. Then the inverse of 2010 in the group Q plus of all positive rationals under the binary operation star defined by A star B equal to AB by 2010 for all A comma B belongs to Q plus is inverse of 2010. So here A star 1 I can say. So no, A star 2010, that is equal to 2010 star A. Since Y both will be equal to 2010 into A by 2010 is equal to A. So it means that 2010 is the identity element. 2010 is the identity element. So it is equal to E actually. E is 2000 for this binary operation star. 2010 is the identity element that the binary operation star. So its inverse, will be itself, since by 2010, so that if A star B, that is equal to B star A, that is equal to E, but E is the identity element, then only we can say that B is the inverse of the element A, that the operation star. So here also we do like 2010 star 2010 equal to 2010 into 2010 divided by 2010 equal to 2000. And okay. So for any other element A star, so 2010, so option C is the correct answer. We have understood. Then it is told that define a relation R on the set A. R maps from the set A to where A set, the set A is as X related to Y if X divides Y. Means that X is a factor of, so the relation R consists of all the ordered pairs X comma such that X is a factor of Y. X is a factor. X divides. So now, therefore, the relation R will contain X. So 1 is a factor of every number. Say there, 1 there, 3 will be. Then 2 is the factor of 4 only. 4 will be. And 3 is not the factor. 2 is a factor of 2 itself. 3 is a factor of 3. 4 is a factor. 3 is a factor of factor. Is a factor of 4. So, and 2 is a factor of 4. So these are the elements. So now 1 comma 1, 2 comma 2, 3 3 4 there. So I can say that A comma A belongs to the relation R for A belongs to the set A. So is that R is reflexive. R is reflexive relation. So R is symmetric, we have to check. Here 1 comma 2 is there, but 2 1 is not. 1 comma 3 belongs to the relation R, but 3 comma 1 does not belong. That the relation R is not symmetric. But here 1 comma 2 is there. 1 comma 2 is there, and 2 4 also belongs to the relation R. This implies, and 1 comma 4 also belongs to the relation R. Is transitive. R is transitive. It means that the relation R is reflexive and transitive. The option A is the correct answer. Relation R is reflexive and transitive. So then the question number 15, the set of all non-zero reals and operation star is defined as A star B 3AB by 2. This group, a solution of 2 star X star 3 inverse. So here set of all non-zero reals. So it means that here A and B should belong to the set R minus 0. Means all real numbers except 0. A and B should not be 0. Here A, so 2 star x star 3 inverse. 3 inverse means 3. That is equal to 4 means 1. You have to find x. So here 2 star x will be 3 by 2 into x. And star by 3 means this is into by 3, 3ab by 2. So this into 3 by 2. That is equal to 4. Cancel here 3, 3 here cancels. This will be 3x by 2. That this will be 3, 6. X is equal to 6. Option C is the correct answer. Then the domain of the function f of we know that if f of y that is equal to sine inverse y, then y should belong to set minus 1 to, then only sine inverse y is defined. So y will be defined only if y belongs to the set minus 1. It means that here log base 2 x by 2 that should be greater than 1 and less than or equal. If we take raised to the power 2 on sides, that will be 2 raised to minus 1, that will be less than by 2, less than or equal to 1. This will be 1 by 2 less than 2 less. Then if we multiply 2 on sides, equal to x, so that will to 1 is less than or equal to x, which is less than. So therefore x belongs to 1 to 4. This is the required domain of the required domain. X should go. Option C is the correct one. So any questions if you have, any steps if you are unable to understand, any doubts if you have, any question or any solution, you can write us in the section. If A and B are have n elements in common, then the number of elements common A cross B and C is. So A cross B is the Cartesian product of A and B, which contains, so you have n elements in common. N elements will be related to elements. Number of elements common. A cross B and B cross A. B cross A. So that will have n square elements in common. Square elements. That's why, since suppose if you take the set A as suppose 1, 1, 2, 3, 4, 5. The set B if we have as like 5, 6. So here A has 5 elements, B has 4 elements, and 2, 3, 4, 5 are common in 3 elements are. So A cross B that will have 5, 4, 20 elements. So it will have 3, 4 and 5 also will be related. 3, 4 and 5 also will be related. 6. So 3, 4, 5 will be related to each other also, like 3 can be related to 3 or 3 can related to 5. 3 into 3, there will be 9 elements in common. B cross A also, if you do, also have the same common elements. It will have, which are 3 comma 3, 3 comma 3 comma 5, all 5 comma 4, 5 comma 4, etc. All those 9 elements which are like 3 into 3, since 3 elements are common, so 3 square you should do. So if n elements are common, then n elements are common in A and B, then n square elements or n square ordered pairs will be the Cartesian product A cross B and B cross A. So hope you have understood. Then if the function f maps from set R to R is the set of all real numbers, is defined by f of x equals to 2x plus 3, then f inverse x. So here it is obviously a 1 1 and onto function. That's why the range is same as the code range of the function f. So all real numbers are, and the codomain is also R. And 1 1, since why, if I take like f of x1 equal to f of x2, then also say that 2x1 plus 3, that is equal to 2 plus 3. We solve it, then we get x1 equal to x1 equal to x2, then only if function f of x1 equal to, therefore it is 1 1. And then therefore if we take y as 2x plus 3, so here it means since f is 1 1 and 1 2, so f inverse will exist. F inverse exists. Y equal to 2x plus 3, so 2x will be equal to y minus 3, so x will be equal to 3, which will be equal to f inverse of y. Therefore f inverse of x, that will be equal to x minus 3 by 2. So therefore f inverse of x, that is x minus 3. Option B is the correct answer. Then in the group Z star, here a is told that a binary operation star is on the set Z. It is on the set of all integers. Means star maps from Z cross Z to Z. A and B should be all integers, and the output, which is A star B, that should be also an integer. Here A star B, that is given as A plus B minus N. A comma belongs to N, where N is a fixed integer, then the inverse of minus N. So inverse. So therefore first we need to find the identity element. Identity element is that A star N, if you do star N, that is equal to N star A, equal to A plus star A. N star A also will be N plus A minus N plus N, which are same, which is equal to. So therefore N is the identity element. So therefore you have to find the inverse of minus N. So if we tell that if A star B is equal to B star A is equal to the identity element E, then we can say that B will be called as the inverse of the element A under the operation star. So here A star B, that should be equal to B star A, that should be equal to N, since here the identity element E, that is N. A star B, that is A plus B minus N, that is equal to B plus A. Since they are commutative, that is equal to n. Therefore I can say that b will be equal to 2n minus a. 2n minus a. 2n minus a is the inverse of the element a. Therefore we have to find the inverse of minus n. Minus n inverse be 2n minus of minus n plus n, that is 3n. So 3n is the 3n is the inverse. So therefore option D is the answer. And then question number 20 here, the range of the function f where bracket x denotes the greatest integer. So we have to find the range of the function f. Range the function f where function f of x is defined as sine of bracket x, where bracket x is, it denotes the greatest integer less than or equal to x. Now you can take case 1, case 2. So in case 1 we can take like x is less than, x is greater than minus pi by 4 and less than 0. So minus pi by 4 means it is slightly greater than minus 1. Slightly greater than minus. Therefore bracket of x, then we can say the bracket of x. So therefore f of x, that sine minus 1 is equal to sine 1. So this will happen for all x belongs to minus pi by 4, 0. In this open interval, the value of the function will be minus sign. Then case 2 is if x is greater than or equal to 0 and less than pi by 4 is slightly less than 1. So then bracket x will be equal to 0. Pi by 4 is less than. Then f of x, that will be equal to sine of bracket x, that is equal to sine of 0 is equal to 0. So these are the two outputs which are really possible in this case. Therefore sine of bracket x can be either equal to 0 or minus sine 1. This is the given interval of x. The given domain, we can say, in the domain of the function f. So therefore the range of the function f, therefore range is 0 or sine 1. Therefore option D is the correct answer. So then number 21, which of one of the following is not correct for features of exponential function given by x equals to b raised to x? Which one of the following function is the features of exponential function? So again, so exponential function f of x is given b power x where b is greater than 1. Greater than 1. Or so then the graph function is like this, power x. B, since b is greater than, here for large negative values of x tend to 0. So the following is not correct either. So first one, option A is correct. We should not choose it as the option. And then option B, it is the domain of the function is R. The set of the domain is obviously R. Domain is R, so B is correct, so we should not choose it as option. And C is the point 1 comma 0 the graph. 1 at point 1 of 1, that is equal to B. It should not be 1 comma 0, it should be 1 comma B. 0 comma 1 it we can say, since why B power 0 is 1. 0 comma 1 is always on the graph. Option C is wrong. So we should choose option C as the answer. Say, and option D also we can check. The range of the function is the set of all positive. Yeah, the range of the function f 0 to all positive real numbers. Okay, D is correct. So only C is the wrong answer. So C should be the correct option. So then let S be the set of all real numbers. A relation R has been defined on the set S. It means R maps from the set S to S. S is the set of all real numbers. A is related to B implies, so R is relation which contains the ordered pairs A comma B, where that mod of absolute value of A minus B should be less than or equal to where A comma B belongs to the set S, which is the set of all real numbers. Set of real numbers told. Of then so here R should contain the elements, so same element should contain. So here you can say that A comma A belongs to the relation R for all A belongs to the set S. Since why? Since absolute value of A minus A, that is equal to 0, which is obviously less than or equal to. So the same element is related to itself. So it is, I can say that the relation R is reflexive, the reflexive relation. And then we know that mod B, absolute value of B minus A equal to absolute value of A minus B. So I can say that if A comma B belongs to the relation R, then this also implies that B comma A will also belong to the relation R. For all A comma B belongs to the set S. So I can say that R is symmetric. And transitive we have to check. So A minus absolute value of A minus B, that is also less than or equal to 1, and absolute value of B minus C, that is also less than or equal to 1. Then we have to check. So suppose for example we have to take example actually here. Suppose absolute value of 1 minus 2, that is equal to 1, is less than or equal to absolute value of 2 minus 3, that is also less than also equal, this is also equal to 1, so which is less than or equal to, but absolute value of 1 minus 3, that is equal to 2, which is not less than or equal to. So therefore here 1 comma 2 and 2 comma 3 will belong to the relation R, but 1 comma 3 does not belong to the relation R, does not belong. So I can say that the relation R is not transitive, it is not a transitive relation, it's not transitive. So the relation R is reflexive and it is symmetric but not transitive. Reflexive, symmetric but not. So option C is the correct answer. So any steps you are unable to understand, or any doubts if you have, please write us in the section. All the homeworks will be uploaded in the Sapience education application. So please install that application, and the link of the Sapience equation application has been provided in the description. Then any two real numbers, an operation star defined by a star b is 1 plus ab. So here a star b is equal to 1 plus ab. So then b star a, we have to find if here the operation star is commutative or it is associative or not. So b star a will be equal to 1 plus ba. So they are the same. Therefore star is commutative. Operation star is commutative. And associative means a star b, that is a star b star c, that will be equal to ab plus 1 plus ab star c. So that will be 1 plus ab plus 1 and ab plus 1 c. That will be 1 plus abc plus c. And a star b star c, a star b star c. So that a star b star c means 1 plus bc. So that will be a, that will be 1 plus a into bc. That will be 1 plus a plus abc. So they are not always same. If a and c are same, then only they are same always. Therefore the operation star is not associative. Associative is that the operation star is commutative but not associative. Commutative, associative. Option B is the correct answer. Then let the function f maps from the set n to n, where n is the set of all natural numbers. Set of all natural numbers defined by f of n, that is equal to n plus 1 by 2 if n is odd, that is equal to n by 2 if it is even. Then f is, so if suppose n is even, if n is even, then it can be of the form 4n plus 4m plus 2, 4m for some m belongs to z, for some m belongs to n, natural number n. So then n by 2, that can be 2m plus 1 or it can be 2m. So it can be even also or it can be odd also. So if n is even, then n by 2 can be even or odd. And if n is odd, then it can be of the form 4m plus 1 3. So then n plus 1 by 2, that will be of the form 4m plus 2 by 2, 4m plus 4 by 2. That will be like 2m plus 1 or it can be 2. So then also it can be even or it can be odd. 2m plus 1 is always odd, 2m plus 2 will be always even. Here also I am saying for some m belongs to n is some natural number. So it means that the output can be, so we have to find if the function f is 1 1 or odd. So suppose for example if I tell f of 4, that will be 4 by 2, which is 2. 4 is an even number. And also then f of suppose 3. F of 3 is an odd number, so it will be 3 plus 1 by 2, that is 4 by 2, which is 2. So therefore f of 4 is equal to f of 3. F of 3 is equal to f of 4, but 3 is not equal to 4. So therefore the function f is not 1. Is not. But here the output is coming odd or even. It means that all natural numbers will be included in the range of the function. So but here the range, so I can say range of the function f is also same as set of natural numbers n. So which is same as the codomain, the function f. Since the codomain is given as n, the range is also given, range also we have obtained as n. So therefore the function f is onto. So f is onto but not 1 1. F is onto. So option A is the correct answer. So in any step, if you are unable to understand any step in the solution, any doubts if you are having, any other chapter if you feel that it is difficult, then we shall solve some more questions on it. So please write your doubts also in the comment section, and whichever chapters you are feeling it is difficult for you, those also you can write in the section. We can proceed. Suppose here it is written the function f of x is equal to x plus 1 whole square, x greater than or equal to plus 1. If g of x is a function whose graph is the reflection of the graph of function f of x in the line y, x is greater than minus 1, greater than or equal to 1. So therefore x plus 1 is greater than or equal to 0. X plus 1 whole square will be greater than or equal to 0. So therefore it is a one function. So it means that we know that the graph so one, okay. So the graph of f of x is somewhat like this. This is y equal to x, and this is the function. It will intersect the axis at the point, intersect the axis at the minus 1, 0. This will be 0. So then its reflection will be somewhat like this. So reflection will be all reflection along reflection of x in the line y equal to x. It means it is the inverse of the function. Now here the function f is 1 1 and on. So if the range is also equal to minus 1 to infinity, and since the domain, since y here the domain is minus 1 to infinity, and the range is, and the range or the codomain, the range and the codomain is 0 to infinity. 0 is included. Since the function f of x will be greater than or equal to 0 always for all x greater than or equal to 1. So the codomain is same as the range, and the function f is 1. So therefore the function f is 1 1 1. So inverse f inverse exists. F inverse x will exist. It is an invertible function. It is an invert. Now we can say that this f of x we can call it as y. Y will be equal to x plus 1 square. Therefore x plus 1 I can say that is equal. Therefore x will be equal to 1 by minus 1. Here y is greater than 0. So therefore this x equal to root y minus 1, this is equal to f inverse of 1. Therefore, f inverse of x only, it is the g of x. Since why it is told that g of x is the reflection of f of x along the line y is the inverse of the function f. That is equal to root x minus 1. Option D is the correct answer. Okay. Then we shall solve our last question. The domain of the function f. Find the function f is root over cos x. So it means that square root or something, this should be greater than 0 always. Cos x should be greater than, and we know that cos x is always less than or equal. It means that the domain. So cos x, the graph of cos x, we know that is somewhat like this. 0, this is pi by 2, 3 pi by 2, pi. From 0 to 1 only we should take value. 0 to pi by 2 we can take pi by 2. In this range, cos x is lying the range 0 to 1. 3 by 2 to 2 pi also. By 2 to pi take. Minus pi by 2 to 0 I can take. Minus pi by 2 also I can take. 3 by 2, 0 to pi by 2, and okay, so in so so 3 pi by 2 to pi, this range cos x is having positive value. 0 to pi by 2, here also it is having positive. 3 pi by 2 to 2 pi, it is having positive value. Minus pi by 2, so it is having positive value. So means we should take 0 to pi by 2, 3 pi by 2 to. Since why in this range cos x is having positive value from 2, option D is the correct answer. So thank you everyone. Shall end the live class here, and please write your doubts. If you have any question, the section, and we shall clarify those doubts in the subsequent live classes. Thank you.